Okay, so here we are. We're going to learn the recursive and explicit formula for geometric sequences. We're just going to hit it and we're going to move on so that you have at least the ability to work your way through this when you come up to it. Even though you don't see it very often, you will need to do this for the final and possibly the EOC. All right, so the recursive formula. Recursive, remember, means that we work backwards. So recursive is only going to let you work with, I can tell you the fifth term if I know the fourth term, the one that comes right before it. I can tell you the 102nd term if I know the 101st term. Okay, so A sub n is the value of the nth term. So if we're talking about the fifth term, A sub n would be the value of the fifth term. Okay? N is the number of term of the sequence. So if we're talking about the fifth term, n would be 5. If we're talking about the 10th term, n would be 10. Okay? And R is the common ratio of the sequence. So whatever we're multiplying by each time, because remember geometric sequences are all about multiplying, where arithmetic sequences were all about adding. So R is that common ratio. Remember, when we were talking about the common form, f of x equals ab to the power of x, b was your common ratio. It's your common ratio here also. All right. Write the recursive formula for this geometric sequence. So here's the formula. We need to find R. Remember, that's the ratio of any two consecutive terms in the sequence. Remember, once again, that's our B. So we can pick any two terms. And we just have to think about what is being multiplied. And it could be a fraction, but what's being multiplied each time? Well, it's being multiplied by 3 each time. So R is 3. There we go. That's all we need to plug in to write our formula. A sub n equals 3 times A sub n minus 1. So what this is telling me is that from any term, I can get the next term by just multiplying the previous term by 3. So let's look at some examples. If I'm looking at A sub 2, the second term in the sequence, that is equal to 3 times A sub 1, the first term in the sequence. Right? 12, that's my second term, equals 3 times first term A sub 1, 4. And sure enough, 12 does equal 3 times 4. Look at another example. A sub 3, that's the third term in the sequence, equals 3 times the previous term, A sub 2. Right? That's why we do A sub n minus 1. We're always looking at the previous term. Well, 36, the third term, equals 3 times 12, the second term. Okay? Alright, so use the recursive formula to find the fifth term of the sequence. Ooh, we got the fourth term. We kind of need that. We're going to write out the recursive formula. That's been done. We're going to plug in 5 for n. How do we know that 5 is n? Because we're looking for the fifth term, right? So we'll write A sub 5 equals R times A sub 5 minus 1 is the way I did it. You could just say 5 sub, or A sub 4. There we go. So I rewrote it for you. If you can skip this step, great. Okay, and now we're going to plug in what for R? We're going to plug in 3 because that's what we figured out by looking at the sequence. R has to be 3. So A sub 5 equals 3 times A sub 4. And next we're going to plug in the value of the fourth term in the sequence. What's the fourth term? 108. So A sub 5 equals 3 times 108. And now we can solve for A. Just multiply that out. Or sorry, solve for A sub 5, the fifth term in the sequence. A sub 5 equals 324. There we go. The fifth term in the sequence. If we continued it, the very next one will be 324. Okay. But remember, the problem with this is that you've got to know what comes before. That's the problem with recursive. It's always looking back at what came before it. If I asked you for the 20th term, you would look at me and roll your eyes because you'd have to know the 19th term to know that. You'd have to look at the 18th term to know that. You'd have to know the 17th term. So you have to work all the way forward. So it's not that useful. So let's look at the explicit formula. Okay, A sub 1 is the first term of the sequence. That is part of the formula. The first term is what we start with. R is the common ratio of the sequence. And n is the number term of the sequence. So a sub 5 would be a sub 1 times r to the power of 5. So that would match minus 1. Does this look familiar at all? It kind of looks like y equals ab to the power of x, doesn't it? Kind of, right? B is r. A is our first term, right? That's always our initial value. That's really similar, isn't it? All right, let's keep going. So what is the 10th term of the following geometric sequence? No, we're not going to do all the math to get up there. First, we're going to... Oh, yeah, sorry. I just wanted to remind you of that one more time, I guess. Okay. First, we're going to write out the explicit formula. A sub n equals a sub 1 times r to the power of n minus 1. We're going to find a sub 1, the first term of the sequence. We're lucky that this time it gave it to us. A sub 1 equals 2. And we're going to plug that in shortly, but to save space, I'm going to wait on that. We're going to go ahead and find r, the ratio of any two consecutive terms of the sequence. Remember, what that means is we can take this term, divide it by that term. Or that term, the 16, divided by 8. Either way, you're going to get your b, or in this case r, of 2. You're multiplying by 2 each time. And now we're going to plug in 10 for n. Why 10 for n? Because we're looking for the 10th term in the formula to find a sub 10. So first let's write out our formula. We have our a sub 1, we have our r, so we can rewrite it. A sub n equals 2, because that's a sub 1, times 2 to the power of n minus 1. There's our explicit formula. We can tell any term from this. And now we're going to tell the 10th term. So we're going to plug 10 in for n. So a sub 10 equals 2 times 2 to the power of 10 minus 1. Let's go ahead and simplify that. A sub 10 equals 2 times 2 to the power of 9. Remember, you can't multiply these out because order of operations says we deal with exponents first. Okay, so now we just need to do the math. A to the power of 10 equals 2 times 512. So did I say a to the power of 10? A sub 10 equals 1024. There we go. There's the 10th term in the sequence. All right, before you look at this and give yourself a headache, I want to change this a little bit. A sub 2, the second term, is going to be negative 15. A sub 4, the fourth term, is going to be negative 375. Go ahead and take a look at that next one and see how you might solve that. Pause if you want to keep thinking. All right, so what we are going to do is we're going to solve this with a system of equations. Really good review, actually, to think about a system of equations. So let's go ahead and write our first equation. We're going to deal with a sub 2 equals negative 15. So there's our explicit formula, and we're going to plug in what we know. A sub 2 equals a sub 1 times r to the power of 2 minus 1, right? We put in 2 for both ends. Okay, and now we still know what a sub 2 is, so let's go ahead and plug that in. So negative 15 equals a sub 1 times r to the power of 1. Yuck, we have two variables. We cannot solve this with only one equation. Let's go ahead and solve it for a sub 1 though. Because if we do, we know that there's going to be an a sub 1 in the other equation for this one. So let's go ahead and solve it for a sub 1. Negative 15 over r to the power of 1 equals a sub 1. Okay, doesn't feel like we're getting anywhere, but we are. Let's go ahead and write the equation for this one. Okay, we're going to use the explicit form. We're going to plug in what we know. There's the explicit form again. A sub n equals a sub 1 times r to the power of n minus 1. Okay, so we're dealing with a sub 4. So let's plug in 4 for n. So a sub 4 equals a sub 1 times r to the power of 4 minus 1. Let's plug in what our value for the fourth term, and at the same time, let's simplify this exponent. Negative 375 equals a sub 1 times r to the power of 3, or r cubed. Let's solve for a sub 1. Negative 375 over r cubed equals a sub 1. All right. Okay. Now we have a system of equations, and we have solved both of them for a sub 1. What can we do? Well, we can set them equal, right? We can substitute this in for that, or this in for that, or just set them equal. So we have negative 15 over r to the 1 equals negative 375 over r cubed. All right, let's multiply both sides times r to the power of 1. Multiply both sides at the same time times r cubed. We'll have negative 15 r cubed equals negative 375 r to the power of 1. Okay. Hey, what can we do? Well, we can divide both sides by, let's get rid of that exponent. There we go, because r to the power of 1 is just r, right? We can divide both sides by r. Let's go ahead and do that. Negative 15 r squared equals negative 375. All right. Let's divide both sides by negative 15. R squared equals 25. Hey, we can figure out what r is now. R equals, hey, remember this little sentence that you didn't care about a second ago? You care now because we don't need to worry about plus or minus 5, right? R equals 5. We now have R. Now what are we going to do? We're going to plug that into either equation to solve for a sub 1. Let's pick that equation. All right, so a sub 4 equals a sub 1 times r to the power of 4 minus 1. So I plugged in that negative 375 for the fourth term equals a sub 1 times, now I'm plugging in r, 5 to the power of 3. Remember, 4 minus 1, 3. Okay, we can solve. Negative 375 equals a sub 1 times 125. Divide both sides by 125. We get negative 3 equals a1. Whew, we have our initial value, our a sub 1, and we have our constant ratio 5. We can write our function, or our equation. A sub n equals negative 3 times 5 to the power of n minus 1. All right, we wrote the explicit formula. That's ugly, huh? But you know what? You've got the ability to work through this if you see another problem like this. All right, see you in class.